All right, this will be a recording to help all the Algebra 1 students study for their final exam. I'm going to go through each question on the review guide, talk through it, make sure that you understand each one as we go through it. So this is going to take a little while. Make sure that you understand what's going on as you do each one of these. This is designed to help you answer questions, not necessarily help you do the review guide. So here we go. Um, you have a parenthesis being raised to an exponent, which means everything in the parenthesis is raised to that exponent. So 3 to the third, x to the ninth, y to the third. Remember, when you have a power raised to another power, you multiply the power. So 27, x to the ninth, y to the third is the correct answer. Next one, again, everything inside the parenthesis, including the negative sign. So the negative 2 is being raised to the fourth, x to the eighth, y to the 12. Negative 2 to the fourth power is a positive 16, so do not be distracted there. Positive 16, x to the eighth, y to the 12. And then the next one is designed in reverse. Which one of these is equivalent to negative 9 to the sixth power? So kind of going through this, adding these two exponents together, you get negative 9 to the fifth. Multiply power to a power, you get negative 9 to the eighth. And you'll notice that I skipped the one. That's the correct one. So again, same situation. You're trying to get 36x to the 12th. So going through here, you're going to get 6 to the 4th, x to the 12th. 6 to the 4th power is not 36. We can go by that one. Next one, multiply and add exponents. Next one, 3x to the third. You get 4 to the third, x to the ninth, which gets you 4 times 4 times 4. So 3 times 4 to the third, x to the 12th. Again, 3 times 4 to the third is much too big. And then the last one, 6 to the second, x to the 10th, x to the second. And so 36, x to the 12th, D is the correct answer. Which expression is equivalent to 16 to the sixth? Again, they're trying to get you to do each one of these as you go using your rules of exponents. The first one you subtract. This is 16 to the second. Second one, 16 to the 10th. Next one, you can go ahead and subtract first if you want, and then take it. So 16 to the sixth, and I'm going to go ahead and stop right there since that's what I'm looking for. Again, they're wanting you to go through each of the answers until you find 2x to the fourth is the answer. Anytime you have a negative power, it's the reciprocal. 32, we get 2 to the negative fourth, x to the negative fourth. 2 to the negative fourth is a fraction. When I move it to the top, you'll get 2 to the fourth on top, x to the fourth on the top. And again, this when you multiply those two together, it's a little bit too big. This one is designed to mess with you a little bit. Only the x gets moved to the top because only the x has a negative power. And then the last one is the correct one. 8 divided by 4, and move the x to the negative fourth to the top, getting you x to the fourth. Multiply straight across, so you get 12, x to the fifth, y to the fourth, over 4, x to the seventh, y to the fifth. And now reduce. 12 divided by 4 is 3, x to the second, and y. And that would be A is the correct answer. Next one, using a calculator here, you're going to go 2.6 times 3.4. Sorry for the interruption there. 2.6 times 3.4 is 8.84 times 10 to the, now you're going to add the exponents, negative third. So now 8.84 times 10 to the negative third, D is the correct answer. Now, it says write the results in scientific notation. This was designed to mess with you. That is the correct answer, not in scientific notation, so please be careful there. Next one, you're going to divide 1.235 divided by 9.5, and you get 0.13. Subtract the exponents, so 10 to the fourth over 10 to the seventh is 10 to the negative third. This number is too small. It needs to go up, which means the exponent needs to go down. So 1.3 times 10 to the negative fourth is the correct answer, B. Simply adding exponents. X to the third times x to the fifth is x to the eighth. This should be an easy one. We've already done those kind of things earlier. 5 to the second raised to the seventh. Go ahead and multiply the exponents. You get 5 to the 14th. Next one. Go ahead and do what's inside the parentheses first, and then a to the 12th. Now they're asking you to actually evaluate a to the 12th. So 2 to the 12th is 4,096. Sorry, I drew a line right through it. B is the correct answer. 2 to the negative second times 2 to the fourth times 2 to the negative third. Adding exponents. Notice I don't change the 2. Negative 2 plus 4 plus negative 3. You end up getting negative 1. And so 2 to the negative first power. Multiply. 3 times 6 is 18. X to the negative first, adding the exponents. Y to the negative second, adding exponents. Negative exponents mean the reciprocal of. So only the x and only the y go to the bottom of the fraction. Anything to the 0 power is 1. 3 to the 7th over 3 to the 4th, subtracting exponents. I get 3 to the 3rd, which is 27. Squaring everything inside the parenthesis, including the negative sign. So negative 2 to the second power, 5 to the second power. C is the correct answer. And the last one here, writing in standard form. Since it's 10 to the positive fourth, you're going to go 1, 2, 3, 4 decimal places, getting you 54,000. A is the correct answer. Scientific notation, this time negative power. 1, 2, 3, 4, 5, 6 zeros, and a 1 value is 3.6 times 10 to the negative 7th. And that concludes our first section. Section 6.2, which expression is different, meaning which one is not the same answer. So if I put this into my calculator, 81 to the 1/4 power, I get 3. Also 3, also 3, but anything to the 0 power is 1. Rewrite the expression now. The number on the bottom is the root. The number on the top is the exponent. And so I'm looking for the cube root of 27 raised to the 4th power, which is 81. Graph the, now here you are given a picture and asked which one of these gets you that picture. And so this can be a little bit confusing. Notice when you have x equaling 0, y is equal to 1/3. So going over here, and I'm going to plug 0 in for each of the x's. So if I plug 0 into the first one, I get 1, so it can't be A. I plug 0 in for x in the second one, I get 1 again, can't be B. I'm going to go all the way down to the bottom one here. I plug 0 in, I get 1 times 6, so it can't be D. And it would be C. Now let's say that worked in multiple problems, then I would then going to go to the ones that it did work in and put 1 in for x and see if you get 2 for y. So here's the next one. I'm going to put 0 in for each of these x's, and I'm looking for 4. So if I put 0 in for x, I need y to equal 4. So the top one, 0 for x, I get 1. 0 for x, I get 1. The next one, 0 for x, you get 0.25. And 0 for x, you get 4. All right, same situation. I'm given 2 points. This time I'm not given 0 as one of my points. So again, now I'm looking for x to be negative 1, y to equal 3. And then if I need to, x to be 1 and y to equal 1/3. So here we go. If I put negative 1 into the top one, I get 3. If I put negative 1 into the second one, I don't. If I put negative 1 into C, I get 6, so no. If I put negative 1 into D, I get 2/3. So the only one, when you plug negative 1 in for x, that gets you 3 is A. The table represents which of the following functions? All right, so now, again, you are looking for a situation in which you plug a value in, you get 4. So I always start with 0. 0 is kind of the easiest one to go with. So if I plug 0 in for x, I need to get 4 for y. So the A, 0 for x gets you 2 for y. B, 0 for x, I actually get 0. C, 0 for x, I get 4. So that's a possibility. And then D, 0 for x, 0 squared times 4. So again, the only one that gets you that Now you could check other values if you want, like plug 1 in, see if you get 8. Plug 2 in, see if you get 16. Again, it should work for every single x, y coordinate. Which table represents the function? Again, I always like to start with the x equaling 0 and y equaling 3. So let's plug 0 in for x and see what we get for y. So the first one, 0 for x, you get 3. So that's a possibility now. B, 0 for x, I get 4, so that doesn't work. 0 for x, I get 3 again, so C is a possibility. And D, 0 for x, I get 1/4. So I'm down to 2 now. Let's plug in the next point. Plug 1 in for x. Well, in the first one, you plug 1 in for x, you get 12. In the C, you plug 1 in for x, you get 7. So the answer to the question, table that represents, the function that represents this particular table is A. What is the percentage of growth for the function? Now, anytime you're asking about percent growth, you're talking about the number above 1. Anytime you're talking about decay, you're talking below 1. So this value right here, 1.95, how much above 1 is it? Well, it's above 1 by 0.95, which is 95%. 200,000 people attended the county fair in the year 2012. The attendance increased by 8% per year. Which function represents the attendance T in 2012? Exponential growth or exponential decay? Because it is increasing, we're going to use the exponential growth formula. The initial amount, 1 plus the rate. Now, I'm going to write this a little bit better. The rate raised to the t. Now, notice it's 8% written as a decimal is 0.08. So C is the correct answer. You deposit $750 into a savings account that pays you, again, 8% interest compounded yearly. Use the formula y is equal to a parentheses 1 plus r raised to t to find how much money your account is after 7 years. So I've got $750, 8% written as a decimal raised to the 7th. So now pulling out a calculator right now and typing that in, 750, 1 plus 0.08 raised to the 7th power, and I would get $1,285.37. This time, I got another savings account, initial amount, savings account that's earning you 3% interest, compounded yearly. How much will be worth again after 7 years? So typing that in, 1,200, 1 plus 0.03 raised to the 7th, I get C. Now remember, anytime the value is above 1, you're talking about growth. And anytime it's below 1, you're talking about decay. And so you'll notice that this is a line, so that's not exponential growth. And this is also a line, so that's not exponential growth. And this one is being raised to the half, being raised to the x power. And this one's 4 is being raised to the x power. So since this one is above 1, being raised to the x power, that would be considered exponential growth. Solving. If the bases are the same, exponents are equal. So 1,296 is going to be the hard part about this. So you're going to end up getting, what you're looking for is what value, okay, so this 6 raised to the negative first, raise the x. 1,296 is, sorry, 6 raised to the 4th power. So I got 6 to the negative x equals 6 raised to the 4th. If the bases are equal, the exponents are equal, so negative x equaling 4, I get x to equal negative 4. Next one, looks like things got off here just a little bit. So I'm not sure what's going to happen here. I want to get the bases to be the same. So this is 3 to the 4x. And let me try that again. I'll show my work a little bit better. This is 3 to the 2nd raised to the 2x equals 3 raised to the x minus 6. What happens when I have a power being raised to a power? I multiply those two powers together. And if the bases are equal, the exponents are equal, and then I solve the algebra question. I get x to be -2. Again, not sure what happened with this right here. So if your review guide is off slightly there, I'm not sure. It looks like cutting and pasting, we might have made a small mistake there. So let's see if I can go to the next one here. All right, adding and subtracting polynomials. Here's what you have to know about adding and subtracting polynomials. Um, you're only allowed to add and subtract like terms, meaning you have to have the same letter, same exponents. Degree of the polynomial is the largest power of any exponent. So I'm looking here. I have -4x to the third plus 6x to the fourth minus 1. This is the largest exponent of any variable, and so therefore 4. Which expression is not a binomial? A binomial is a single term. And so each one of these, this one has 2 variables. Hold on one quick second here. I'm going to pause, so give me a second. I apologize for the technical difficulties there. All right, so we're back. Which one of these is not a binomial? The last one here has a negative power. You can't divide by a variable, and so therefore D is not a binomial. We're subtracting. I don't have a lot of space here, so I'll do my best. You have 5x to the third plus 2x squared minus 7x plus 9 plus, and I'm going to change all the signs here, 4x to the third minus 3x squared minus 2x minus 1, and I'm only going to add together the like ones. So 5x to the third and 4x to the third make 9x to the third, plus 2x squared and a minus 3x squared makes a -1x squared. -7x minus 2x makes -9x, and 9 and 1 make +8. Be very careful on your final exam. Again, all of these are going to be close. There's going to be a few subtle differences every time, so please make sure that you get the right one, and B is the correct answer. Next one. Add the like terms together, you get 12x squared plus 10. Again, being very careful to make sure you grab the correct one there. Dimensions of a rectangle. All right, do not be alarmed about geometry here. You guys know basic formulas for area of rectangle. Area of a rectangle is base times height, or length times width. Now it's your foiling skills. I know the next question has a foiling question as well. Let's talk about foiling. First, outer, inner, and last. Those of you in my class would know. Makes a little smiley face. Add together the like terms, x squared plus 5x plus 6. So now let's do this again, and I'm going to go slow motion through it one more time. The first term in each parenthesis gets multiplied together. The outer terms in each parenthesis get multiplied together. The inner term in each parenthesis gets multiplied together. And the last term in each parenthesis gets multiplied together. So now, adding the like terms together, I get 8x squared minus 34x minus 9. Be very careful. Make sure you grab the correct one. Notice each one of these, you have an 8x squared, and some of them have 34, and some of them don't. Some of them have a -9, all of them have a -9. So please make sure that you're very careful in getting the correct answer. More foiling questions. I'm going to go quicker now, though. 6x squared plus 8x minus 15x minus 20. Adding the like terms together. So 6x squared minus 7x minus 20. A is the correct answer. This one is a special product. It doesn't change your foiling. It just means that the middle term, as you are multiplying these two together, are actually going to cancel each other out, leaving you with 36x squared minus 4. And then the last foiling question, I believe, that we have here, b squared plus 2b minus 8b minus 16. Adding the like terms together. And again, you got to be really careful which one you're going to get is A. 3x minus 5 squared. Please do not just square both terms inside there. Please make sure that you FOIL this out. You end up getting 9x squared minus 15 and another minus 15 makes a minus 30x plus 25. So skipping some steps there, but C is the correct answer. Next, and again, the word product, now we're using some vocabulary. You're asking you to multiply a monomial times, in this case, a polynomial. So you're going to distribute using our rules of exponents now. Negative 2x to the fifth. Be careful there. Okay, when multiplying, you always add exponents. Plus 10x to the fourth minus 4x to the third plus 2x to the second. So again, looking up there, being very careful to make sure you get the correct one and all the signs are right. You don't want to miss a problem on the final exam because you got the right answer and then you didn't look carefully enough at which one is the correct one. Okay, make sure that each term, notice how close B is to C. Okay, they're literally off by one term. More multiplying, so 2x minus 3 times 2x minus 3. And so I'm going to FOIL again. 4x squared minus 6x plus 9. Adding the like terms together, I get 4x squared minus 12x plus 9. And then the last one here, I believe, 49m squared minus 56m, another minus 56m, and a plus 64. Okay, make a smiley face out of this one. Adding the like terms together, we get C is your correct answer. Anytime you are solving polynomials in factored form, everything that is factored, it's set equal to 0. Okay, every time you see a variable, you set it equal to 0. So this one, 0. This one, 0. This one, 0. And solve each one of those. And I know I don't have a lot of space here, but x equaling 0, x equaling 6, and x equaling negative 7/2. Be careful again. C and D are very close to each other. And if you're not careful, you'll get the wrong answer. So the next one, I got a little more space here. Y minus 12 equals 0. Y, the board went a little funny there. Hold on. Y plus 6 equaling 0. So I solve this. I get y to equal 12. Y to equal negative 6. C is the correct answer. All right. Everything that you are going to solve by factoring must equal 0. So I subtracted x from both sides so that it equaled 0. Now, let's talk about factoring. The first factoring that we learned was taking out the GCF. I can take an x out of both of those. Now, from the previous slide, anytime you're in factored form, set it equal to 0. So x is equal to 0, and 4x minus 1 is equaling to 0. So I get 1/4 and 0 as my correct answer. So the next one, let's do the same thing now. Let's see how we do. I can take a 9x out of both. So 9x equals 0, x minus 3 equals 0, and I solve both. So I get x to equal 0 and x to equal 3. Already in factored form again, so set the parentheses equal to 0. So I get x to be negative 4 and x to equal positive 12. So as you're going through this, make sure that you get the correct one, negative 4 and positive 12. Back to factoring it myself. Both of them are a GCF of 4n. Set them equal to 0 and solve. So I get 0 and 5 as the correct answers. Factoring now. All right. Again, greatest common factor is the first thing that we talked about with factoring. So I'm looking at this one. 14, 28, and 35 are all divisible by 7. X to the fifth, x to the fourth, x to the third. I can take 3 x's away from all of them. So now divide by 7 and take away 3 x's. So I get 2x to the second minus 4x plus 5. Now, again, be very careful as to which one it is, and C is the correct answer. All right, factoring x squared plus 3x minus 28. You'll notice there's no number in front of the x squared. So in front of x squared is no number. So all you need to do are factors of negative 28 that would add up to positive 3. For those of you that struggle on your times table, okay, please make sure you go through and try to come up with the number that will work here. All right, you're looking for two things that will multiply to be negative 28, and the signs do matter. So a positive 7 times a negative 4 multiplies to be negative 28 and adds up to be 3. Since there is no number in front, you can go straight to the answer. Those magic numbers will turn into your parentheses, x plus 7 and x minus 4. Now, I'm going to tell you guys a little bit of a secret. Those of you that are actually doing this, listening to this video and struggling with factoring, look at each one of your answers. If you are really good at your foiling skills, you could actually foil the answers to see which one of those will actually get you that trinomial. Only one of these, when you FOIL it out, will get you that trinomial. So again, those of you that are listening to this video and need a little extra assistance on factoring, think of your answers and foiling, and you can always figure out which one it's going to be. All right, so now it's a factor and a solve. So I put both of these things together. X squared minus 3x minus 10 equaling 0. So I need factors of negative 10. That would add up to negative 3. So in factored form, this would be x minus 5 and x plus 2. Set the parentheses equal to 0. So x minus 5 equaling 0, x plus 2 equaling 0. Solve both of those. And again, due to space constraints, I'll go ahead and just give you the answer there. Now, 57, make sure that it equals 0 before you start factoring. So I need factors of negative 240. Factors of negative 240, they're going to add up to negative 8. So this is a little bit more challenging because the numbers are so big. But negative 20 times positive 12 would work. So now set the parentheses equal to 0. I get x to be positive 20 and x to be negative 12. Next one. Order does matter. Okay, you always need it in what's called descending order, highest power to lowest power. So now, factors of negative 26, that's going to add up to negative 11. Again, those of you that struggle with your times tables, this is a bit of a struggle here. So I've got negative 13 and positive 2. Set the parentheses equal to 0 and solve. So positive 13, negative 2, A is the correct answer. Which one of these is a factor of the trinomial? Don't look at the answers here, just factor it. So x squared plus 6x minus 27. Factors of negative 27, that would add up to 6. I need a positive 9 and a negative 3. So now I'm looking for one of those up here. And so x plus 9 is one of the factors when you factor this. Notice the other one is not listed here. So this is trying to stop people from foiling out the answers to see which one it is. We put this in here just to make sure that you understand that. More factoring. This will be factoring with the lead coefficient now. All right, so I have 6x to the second minus 13x minus 5. This is the hardest portion of the entire chapter, is right here. Now, because there's a lead coefficient, I need to multiply the outside two numbers together and then do the same thing that I have been doing. So factors of negative 30, that would get you negative 13, would be negative 15 and positive 2. Here's where things get a lot different. I need to set the outer as one of those two numbers. So either negative 15 or positive 2. Doesn't matter which one. In fact, I'm going to use negative 15. Using a factor of the first number. So see this 6? Using a factor of the first number and a factor of the last number, I need to get negative 15. And I got that. Now it's a matter of filling in the blanks. 3x times 2x gets you 6x squared. So the first one in each term, or excuse me, the first one in each parenthesis must equal the first term. And then the last one in each parenthesis must equal the last term. So notice 1 times negative 5 is negative 5. So now, which one did I get? 3x plus 1, 2x minus 5. D is the correct answer. Let's keep practicing that now. I'm going to multiply these outside two numbers together. I'm going to get 60. I need factors of 60 that would add up to 19. Okay, a little bit more challenging there. 15 and 4 is the correct answer. So here's my parenthesis. Remember I said positive 15, positive 4. So I'm going to set the outer as one of those two. Let's do 15 again. So I need a factor of 10 here. Oops, sorry. A factor of 10 here, and then a factor of 6 here. So notice that from the beginning, the 10x squared, I needed a factor of the first term to go in the first spot, and a factor of the last term to go in the last spot, and it had to multiply to be plus 15. So that's a pretty specific situation there. Now, filling in the blanks, 10x squared times 5x times 2x is 10x squared, and 3 times 2, and so I get 5x plus 2 and 2x plus 3. B is the correct answer. Next one, solve the quadratic equation by factoring. So really this should equal 0 if we're going to be solving by factoring. So let's multiply the outside two numbers together. I get negative 30 that add up to 13. So you're talking about 15 and negative 2. Set the outer. So I'm going to set the outer as positive 15. And now taking a factor of the first one and a factor of the last one, I need to get 15. And then first times first must be equal first term. Last times last must equal last term. And now let's talk about solving. Set the parentheses equal to 0. So adding 1 and dividing, I get positive 1/3. Subtracting 5 and dividing, I get negative 5/2. And so I'm looking for positive 1/3 and negative 5/2. A is the correct answer. Rectangle length is 13 more than 3 times the width, and the area is 10 square centimeters. All right, so the length is 13 more than 3 times the width. So I'm going to draw a little picture here. And so 13 more than 3 times the width, and then the width is just W, and the area is 10. So down here at the bottom, so I have W times 3W plus 13 equals 10. Distribute. So I get 3W squared plus 13W equals 10. Subtract 10 so that it equals 0. And now we're back to factoring again. Negative 30. That would get you 13. And I think we've actually had that exact situation before. 15 and negative 2. I'm going to set the outer as one of those two numbers. And so I need a factor of the first times a factor of the last. And then first times first, last times last. I end up getting x to equal 2/3 and x to equal 5. And so now, what is the actual width? I'm sorry, x to equal negative 5. So the only one that it could be is 2/3 because you can't have a negative width. All right, I'm going to erase this just to give myself space again. So I'm going to erase this. So those of you that are listening to this and whatever, I'm going to erase this one right now. And now I'm going to factor this one. So I'm going to multiply the outside two numbers together to be negative 60. Factors of negative 60 will get you negative 7, will be negative 12 and 5. Again, set the outer. I'm going to set the outer this time as negative 12. I need a factor of the first term here in the first spot. I need a factor of the last term then in the last spot. First times first has to get you the first term. Last times last has to get you the last term. And then set these equal to 0. So I've got 2m plus 5 equaling 0. M would be negative 5 halves. M minus 6 equaling 0. M would equal 6. So my two answers are negative 5 halves and positive 6. D is the correct answer. Special products now, okay? The first one's actually a special product and a solve question, so make sure that it equals 0. There's only two terms here. And I know that some of you is solving by factoring, but I'm going to show you can also solve this in another method that you learned later. Is the first one a perfect square? Yes. 6 times 6. Is the last one a perfect square? Yes. 5 times 5. 1 plus 1 minus. Solving now, set the parentheses equal to 0. So 6x plus 5 equals 0. 6x minus 5 equals 0. I get x to be positive 5/6, x to be negative 5/6. B is the correct answer. Now, I want to show this off to the side here. Could I have, this goes now and later, divide both sides by 36 and taken the square root of both sides, which gives you a plus or minus 5/6. So again, I'm just trying to show you that later you did learn a different way to do this one. A square quilt has a border of 1 foot on each side. The quilt has an area of 25 square feet. What is the side length of the quilt without the border? So again, you're going to take the border off the quilt, and it's a square. Okay, so this we're talking about x minus 1, and this would be x minus 1. So the quilt has an area of 25 feet. The square quilt has a border with 1 foot wide on each side. The quilt has an area of 25 square feet. What is the side length of the quilt without the border? So now, going back over here, hold on. So now you're talking about x squared equals 25. So x is equal to plus or minus 5. So 5 is the only answer there. So the square quilt has a border of 1 foot on each side. The quilt has an area of 25 square feet. What is the quilt without the border? So if 5 is the quilt, then 4 feet is without the border. Factor completely. All right. Is there a GCF? Is there something I can take out of everything? Well, I can take out, both of them are divisible by negative 5. So I get 9x squared minus 4y squared. Is the first one a perfect square? Yes. 3x and 3x. Is the last one a perfect square? Yes. 2y and 2y. Since it's a minus sign, one's plus, one's minus. And so negative 5, 3x plus 2y, 3x minus 2y. C is the correct answer. More factoring questions, all right? Now, this is a special factoring, but again, most of you are just going to factor this like normal. You're going to multiply the outside two numbers together and get 16. Factors of 16 that would get you negative 8 are negative 4 and negative 4. Set the outer. So I need a factor of 16 in the first spot, factor of 1. Now, first times first must equal the first term, last times last. So I'm looking for 4x minus 1, quantity squared. And then 69, the first one's perfect square, second one's a perfect square, and a minus sign. So you're talking about 5x minus 12 and 5x plus 12. So D is the correct answer. Is there a GCF? They are both divisible by 4x. Factor again, because you can, two perfect squares, x and x, 3 times 3, one's plus, one's minus. So A is the correct answer. Next one, grouping. We haven't done this yet now, so I'm going to do x cubed minus 2x squared minus 9x plus 18 equaling 0. Is there a GCF of the first two terms? Well, I can take an x squared out of both of those. I can take a negative 9 out of the second two, and this will happen every single time. Anytime you are factoring by grouping, the parentheses will be the same. So x squared minus 9, you group what's in front, keep what's the same. Now, this one is a bit rough because this first one is factorable again. They are both perfect squares, so x and x. And now I set every single one of these parentheses equal to 0, and I'm going to get positive 3, negative 3, and positive 2, which is C is the correct answer. Find the vertex of the function. This should say y equals negative 3/4 x squared plus 7. I'm looking for vertex. If you remember right, it's negative b over 2a, or if you're in vertex form, you can find the vertex that way. This one actually is considered vertex form, but you can also get this to be 0 because you have negative b over 2a. So you get 0 for x. Plug 0 in, you get 0, positive 7. Find the y-intercept and the axis of symmetry for the function. All right, we're going back to negative b over 2a. So I have negative 40 divided by 20 is negative 2. Plug negative 2 back in. Plug negative 2 back in. That will get you the vertex. It's not asking you for the vertex, so I'm going to stop right there. X equals negative 2 then is the axis of symmetry. Now, the y-intercept is always the C value. So you're talking about 0, 42 is the y-intercept. So I need negative 2 as your axis of symmetry and 42 as your y-intercept. So C is the correct answer. Next one, find the vertex. Negative b over 2a. So negative 8 divided by negative 4 is positive 2. Plugging positive 2 back in, you get 7. And which direction does it go? Well, if it has a negative out in front, the a value right here will tell you whether or not it goes up or down. So since that's negative, it is 2, 7, and a down. Maximum or minimum value, again, find the vertex. So negative b over 2a, I get 1. Plug 1 back in, I get negative 1. Since this parabola goes down, we're talking about a max value. And so I need a maximum of negative 1, and that's C. Axis of symmetry is x equals 5. So again, now I'm going to have to go negative b over 2a for each one of these until I get the right one to be x is equal to 5. So let's talk about the first one. We got positive 5 over 2 times 1, so it's not going to be a. Negative 10 over 2 times 1 is negative 5. So this one's an x equals negative 5, which is still not right. How about positive 10 over 2 times 1? This is x is equal to 5. And then the last one, negative 5 over 2 times 1, okay, would not work as well. Find the vertex. So a lot of negative b over 2a. You need to know that formula. 4. Plug 4 back in, you get 17. When I say plug 4 back in, that means I'm going negative 2 times 4 squared plus 16 times 4 minus 15, and I'm going to get D as the correct answer. All right, so again, they are giving you a point, the vertex point, and they are giving you another, the y-intercept in this particular case, and it's going downward. So right now, I actually could rule out some of these because I know that the parabola is going down, so the a value has to be negative. So that's one way to kind of rule some stuff down. But let's go negative b over 2a. If the first one, negative 8 over 2 times negative 2, I end up getting positive 2. And when I plug that back in, I end up getting 16. Sorry about that. I get 11 for my vertex. Well, does that work then in the first one? Okay, I got a vertex for the first one to be 211. Well, my picture doesn't have a vertex at 211. Let's try B now. Negative B over 2A. I end up getting positive 2. And when I plug positive 2 in, I get 5. And so B is the correct answer. Okay, this is C is going up and D is going up. And so the only one this could be is B. Now, this is vertex form. I know I mentioned it just a little bit earlier, but vertex form, okay, the value that makes this 0, so negative 3, and the value outside is the vertex. So now, which quadratic on the next one has a vertex at negative 3, positive 5? Okay, it's not A. B is actually backwards, right? The x should be inside the parenthesis, not the x outside the parenthesis. And so B is the correct answer. Again, the signs matter here. This would be a positive 3, positive 5. So now I'm looking for a vertex at 3, 2, positive 3, positive 2. So let's go over to the pictures now, or go over to the equations, and look for positive 3, positive 2. So the first one, could that be the correct answer? Maybe. Okay, positive 3, positive 2 is the vertex. B, again, positive 3, positive 2. Next one, negative 3, negative 2, and negative 3, negative 2 again. So it's not those two. So now it's a matter of which one has the other point. Okay, the other point that you are given is, and I know it's hard to read here, but the other point you are given is negative 1, negative 2. So I need negative 1, negative 2 to work in the problem. Okay, so let's put negative 1 into the top equation. Negative 4, negative 1, minus 3 squared plus 2. So wait a minute. Negative 4 squared is 64 times negative 4 would be way too big. Okay, so it can't be A. It's got to be B. Let's see if it works. Is negative 1/4, negative 1 minus 3 squared plus 2. Does it equal negative 2? 4, 4, 4. And it does. Okay. Next one. Which quadratic function has zeros at negative 4 and negative 7? Intercept form. Okay, so x plus 7, x plus 4, okay, and x minus 7. These are the values that x equals, which create the parentheses x plus 4 and x minus 7. So A is the only one that has an x plus 4 and an x minus 7. Next one, what are the x-intercepts? Again, setting the parentheses equal to 0. Sorry about that. X is equal to negative 1. X is equal to positive 7. So A are the x-intercepts. Determine whether the equation is linear, quadratic, or exponential. Linear, you have no exponents. Okay, x is to the first power. So this one would be a linear equation. Next one, notice it's raised to the second power. That is a quadratic. In order to be exponential, it had to be raised to the x power. And so plot the points, then state whether they represent a linear exponential. So 0, negative 4. I'm going to change colors here for you. 1, 2, 3, 0, negative 4. 1, negative 2. Negative 2, positive 4. Or positive 2, 4, sorry. 1, 2, 3, 4. Negative 1, negative 2. and -2, +4. So what kind of picture is this? This is a quadratic. And I'm going to stop right here just to give you a halfway point and to stop the video for a little bit. So if you have any questions, make sure you talk to your teacher, and we'll stop the video and give you a chance to rest.